All right, so if we look at the answers to the second question, it is states like Texas, Illinois, and California which suffer the greatest loss of life from natural hazards. Illinois and California mostly suffer due to heat waves, and this is partly because they're both so densely populated. And then Texas is not as greatly populated, but it is very large and is prone to severe weather and to flooding, especially. Both of those things tend to be pretty merciless towards living beings, which is why they fall under one of the states for this um, greatest loss of life question. So I also want to make an annotation here, and that is that the natural hazards that say are mostly responsible for loss of life in California and Illinois again are heat waves. And although this is true, it is important to clarify that heat waves are especially harmful to those who have underlying health conditions. So this is tough to attribute loss of life to solely the natural hazard in many cases. Okay, so where on the surface of our planet are we likely to see which types of natural hazards? Let's first consider just the United States for starters. So a lot of it is pretty intuitive, but we can go through some of these hazards, especially the ones that are outlined here on the map, and look at them in detail. So if we look at the western US, where we have ongoing current volcanic activity in the Cascade Mountains, for example, from volcanoes like St. Helens, which erupted in 1980, as some of you may know, like Mount Rainier, Mount Hood, Mount Shasta, etc., as well as some unrelated volcanic fields like Yellowstone, for example. We see that the volcanic hazard, which again is this red scheme that you're seeing, is considered as high in many places, so near those volcanic areas, and then it lowers the further away you get from those volcanoes, basically. So the communities that are nearby the high hazardous area should be at greater risk for a natural disaster to occur. So that is one of those hazards. Sorry. There is a reason why the Cascades are so volcanically active. Hopefully after next lecture on plate tectonics, and later on after we cover chapter 5 on volcanoes, you will actually understand why that is. But for now, let's just know that they are. And so that's why the hazard presents itself as high in that slide. Also in the western US, there is a greater likelihood for earthquakes and seismic activity, and this is also due to plate tectonics. So after next lecture, again, it will make a lot more sense to you why that is. But again, if you're looking at earthquakes, which is this kind of yellow-orange color scheme, you see that it mostly presents here in the border of California, Oregon, a little bit of Washington, and also a little bit in the Rockies. So we'll look at that in a little bit more detail when we cover plate tectonics and earthquakes as the next two chapters. If we look at the eastern part of the US for comparison, we see that the likelihood of hurricanes is actually very clear. So hurricanes here appears as purple and lighter colored blues in the color scheme. And they're especially clear, or the threat of it is especially clear in coastal areas that are closer to the Gulf, right, and closer to the lower latitudes. So areas here in the eastern Atlantic coast and areas here in the Gulf, pretty clear to be at risk. So these hurricanes typically start as tropical depressions and as tropical storms somewhere in the Atlantic Ocean, closer to Africa actually, and as they continue to build up in energy and in size, they will migrate northwest towards the Caribbean and then onto North America, basically. So the Caribbean and North America are both places that see their communities constantly affected by this tropical cyclonic activity. We also see that the east is actually typically more prone to flooding than the west. So flooding is this kind of darker blue color. So you're seeing that sure there's a little bit here in the Dakotas and in Minnesota, but overall there's not too much in the west compared as the one that we see kind of throughout the eastern states. The flooding that we do see in the west, we see it's mostly in Arizona and in New Mexico, and a little bit in Idaho, Montana, Washington, Oregon area. The one that we see in Arizona and New Mexico typically is from flash floods that we receive. And then in Montana, Washington, and Idaho, it tends to be from just spring snow melt. So there's just overly saturated slopes typically, or even just rivers that get overly saturated, and so they flood over onto the floodplain. So the east has a lot less mountainous areas than the west does. Here we have the Rockies, which are massive. Sure, the east has the Appalachians, but overall it is mostly flatter than the west part of the U.S. is. And so a lot more precipitation on average also falls on the east based on just atmospheric circulation that we have. So it being flatter and having more precipitation overall it allows for the water that does fall to accumulate at the surface as runoff. So remember that water can accumulate as runoff, it can percolate, it can infiltrate, so on and so forth. So in this case, because there's already greater amounts of water and less places for it to flow, it's likely to accumulate as runoff, so just sit atop the surface and hence cause flooding. So also in the Midwest, you can see a little bit of flooding, again over here, but the Midwest itself is mostly prone to tornado activity, as we're seeing here on the map. And that has to do also with atmospheric conditions and also with topography mostly. So all of these natural hazards we'll look at in detail as we go through the course. So don't worry if I'm going kind of fast and maybe you're not getting the full gist of it. We'll look at them in detail as we go through the course. So typically you're mostly familiar with those hazards that occur in areas where you live in the US. For example, here in Idaho, we're mostly familiar with wildfires, maybe some flash floods, rock falls, and perhaps avalanches every now and then. Often enough, we also have seismic activity occurring. And again, we'll go over why that is later in the course. But that's what we mostly see in our state. Okay, so what does it take for a natural hazard to become a disaster? I've said many times that yes, it has to do with population and it has to do with property, but what is it exactly? So in order for a hazard to become a disaster, one of these 4 criteria listed on the slide have to be met. One at least, maybe more. So the first criteria says that 10 or more people have to be killed in order for that natural hazard to be characterized as a disaster. Second criteria says that 100 or more people have to be affected. And so here, by affected, it can mean that people are injured. It can mean that their homes or their crops or businesses got destroyed or partially destroyed, or maybe just greatly damaged. All of those would fall under people being affected. The third criteria is when the state of emergency is declared. So for example, in the spring of 2017, the state of Idaho declared a state of emergency for the town of Eagle. And this was because the Boise River was so high that many neighborhoods saw flooding and many people were actually asked to evacuate, even with the management of water that happens in the dam above, or in the dams, I should say, that happen above. So the dams basically were already holding too much water in the reservoir, and they were only going to see more water from the snow melting further uphill in the forest, and so they couldn't just keep holding all of that water, which caused many places of the Boise River to flood over the typical level that they see. And so the state itself declared a state of emergency for the town of Eagle. And then the fourth criteria says that international assistance is requested. So, for example, this happens almost every year here in the Western US when we have our very great fire seasons, as you are probably aware of. So many a times, teams from Chile, from Australia, from South Africa, Northern Europe, Scandinavian countries, Mediterranean countries, all of those make their way here to the US to help, and vice versa, when we have this tough fire seasons. It's useful when you have Southern Hemisphere countries coming in to help because our fire seasons are reversed. So you see a lot of people, like a lot of firemen from Australia and South Africa, and sometimes from Chile, to come and help with the fire seasons that we have here in the Western US. So that, again, international assistance requested would qualify that natural hazard as a disaster. So again, those are the four criteria, out of which at least one must happen before a natural hazard is classified as a disaster. And so natural disasters will typically require a considerable amount of time and money for remediation. And if the amount of time and money needed surpasses a certain quantity, then that disaster is considered a catastrophe. That quantity that it needs to surpass is kind of subjective, so it's a little bit arm wavy in that sense. But let's go with a few examples. So a good example of what a natural catastrophe is the Haiti earthquake from 2010. So if you want a little bit more detail on this Haiti earthquake, I would suggest that you go to the chapter in your book at the beginning of the chapter. This earthquake, or the consequences of this earthquake are kind of talked about, and it outlines the event right at the beginning pretty well. Another example of a catastrophe is Puerto Rico. So Puerto Rico, as you might know, experienced a lot of damages after Hurricane Maria in 2017. So Hurricane Maria left the territory without electricity, and parts of the territory did not regain it for several months. So several months without electricity in many parts, and there were a lot of buildings completely or partially destroyed. There was no food, there was no water or toiletries to be found in the stores. Obviously, this didn't last incredibly long, the food and water supplies not being there, but long enough to make things desperate. I've heard actually that it was easier to get like Coca-Cola or any soda than potable water for a few weeks, if not months. And also, many people lost their jobs. Many of the crops died, and I think that it was close to 150,000 people that left the territory altogether, and they went to the mainland and the US to make a new life. So overall, the state under which Puerto Rico was left after Maria, or how Haiti as a country was left after the 2010 earthquakes, are both really good examples of what natural catastrophes are. So in both of these cases, it took, or it's still taking, years for recovery of said territories or countries or states, whatever it is. But again, the amount of time and the amount of money that is considered or that is needed for a disaster to become a catastrophe is not objective. There's not a particular set of time or money. It's really up to the place and up to the natural process that happened. So again, that criteria is very definite when you declare a disaster. You need one of those four conditions. But the criteria is not clear when you are declaring a catastrophe. It's definitely more subjective. But again, to recover from a catastrophe, it will take years to decades, whether recovering from a disaster takes maybe years, so maybe up to 5 years. A catastrophe sometimes takes a lot longer and a considerable whole lot more of money.